Hello students, today I will discuss about the application of Biot-Savart law. This channel provides you the physics lecture for class 11, 12, NEET and JEE in English version as well as in Bengali version. To see the unit-wise video lecture, go to the playlist of this channel. So let's start. There are two main applications of Biot-Savart law. One is calculation of magnetic field due to a straight current carrying wire, and another is magnetic field due to a circular current carrying wire. So using Biot-Savart law, you have to calculate magnetic field due to a straight current carrying wire. So suppose this is a straight current carrying wire of current I. So you want to calculate magnetic field at point P at a distance. Suppose this distance is D from this current carrying wire. So using Biot-Savart law, you have to calculate magnetic field at P due to this current carrying wire. In previous lecture, we have learned that Biot-Savart law is applicable due to a current element. So you have to choose current element. So how to choose current element? You have to take current element dl at a distance L from this point. So go distance L, then you have to take a current element dl. So the direction of this current element along this direction. Now the distance P from this current element, suppose this is distance is R. This is R. So here if I take this angle is theta, then this is 90 degree, this is 90 degree, then this angle will be 90 degree minus theta. So if this is 90 degree minus theta, then this angle will be 90 degree plus theta, because total angle must be 180 degree. That's why if this is 90 degree minus theta, then it must be 90 degree plus theta. So the angle between current element ideal and distance R vector is 90 degree plus theta. This is the angle of current element ideal. This is current element ideal and distance vector. So if I use Biot-Savart law to calculate magnetic field at P, then the magnetic field at P due to current element ideal will be, suppose this is magnetic field is dB. So dB will be mu 0 by 4 pi I dl sine, suppose this is vector sine 90 degree plus theta, because the angle between current element and the distance vector is 90 degree plus theta. That's why it will be ideal sine 90 degree plus theta by r squared. So it will be mu 0 by 4 pi I dl sine 90 degree plus theta will be cos theta. So it will be 1 by r square. So this is the magnetic field due to the current element dl at P. Now this equation can be converted at a function, only function of theta, so that we can integrate all over this current carrying wire. So to convert this equation as a function of theta, use this triangle. This is a triangle. Using this triangle, you have to take tan theta. So tan theta will be L divided by D. So L equals to D tan theta. So if I take derivatives with respect to theta, then it will be dl will be d sec square theta d theta. Suppose this is number 1, suppose this is number 2. Another is, if you take cos theta, because there is a r, so if you take cos theta equals to d by r. So then r will be d by cos theta, so it will be d sec theta. This is number 3. So if you put the values of dl, here is dl, here is r, then it will be mu 0 I by 4 pi, here is dl is d into sec square theta d theta divided by, here is r square, so r square will be d square sec square theta, and here will be, there is a cos theta. So this term is cancel out, and one d is cancel out, so mu 0 I by 4 pi d, here will be cos theta d theta. So this is the magnetic field due to this current element IDL. So if I integrate, so suppose this is angle, suppose this angle is minus theta 2. If I take this angle plus theta 2, theta 1. If I take this angle plus theta 1, then this angle will be minus theta 1, because this is reverse direction. So if I take this angle is as a theta 1, then the reverse angle, this angle is reversed, so that it can be taken as minus theta 2. So the magnetic field due to the hole wire will be B equals to integration of dV from minus theta 2 to plus theta 1. So using this integration, we can calculate the magnetic field at P due to this whole current carrying wire. So if you put this value, then this is minus theta 2, here is plus theta 1, then this function is constant. This function is constant. So it will be mu 0 I by 4 pi d, and here is cos theta d theta. So it will be mu 0 I by 4 pi d. Here the integration cos theta is sin theta. So sin theta is minus theta 2, here is plus theta 1. So it will be mu 0 I by 4 pi d. Here is sin theta 1 minus sin of minus theta 2. So it will be mu 0 I by 4 pi d. Here is sin theta 1, here is, because sin of minus theta is minus sin theta, so that's why it will be minus theta 2. This is the equation of magnetic field due to a long current carrying wire. So you have to memorize this equation. So here you see the equation is magnetic field is mu 0 I by 4 pi d into sin theta 1 plus sin theta 2. This is the equation. So I have deduct the magnetic field at P due to this current carrying wire. Now there are some special case. So now I will discuss about some special case of this situation. Number one. If you want to calculate magnetic field on a perpendicular bisector, magnetic field on a perpendicular bisector, So this is the angle, this is the, suppose this length of this wire is L, the current is suppose I, and you have to calculate perpendicular bisector, that means this is distance D, and this must be L by 2 and this must be L by 2. So you have to calculate magnetic field at P. Here this is, both angle must be equals to theta, because here perpendicular bisector. So using this formula we can calculate magnetic field at P. So it will be, magnetic field at P will be, here is theta equals to theta 2 equals to theta, because both angle must be equal. Then magnetic field will be mu 0 I by 4 pi d, here is sin theta plus sin theta. So it will be mu 0 I by 4 pi d into 2 sin theta. So if you want to calculate the value sin theta in terms of d and L, the value of this side will be d square plus L by 2 whole square. So if you put the value of sin theta, then it will be, what is the sin theta? This is theta. Sin theta equals to L by 2 divided by L by 2 divided by this side. So this side is this square plus L by 2 whole square. So these two will be cancel out. So it will be mu 0 I by 4 pi d into L root over d square plus L square by 4. This is the magnetic field at P for a current carrying wire of length L on a bisector point. Okay, so here I will discuss about only the magnitude of magnetic field. Now if you want to direction, then how to calculate direction? You have to use the vector product. What was the formula of Biot-Savart law? Formula is dB equals to mu 0 I dl cross r unit vector by r square divided by 4 pi. So using this cross product, you can calculate the direction of this magnetic field. So suppose this is the direction of current element. So this is the direction of dl. So this is the direction of distance. So dl cross r. So dl cross r into this plane. So into this plane, that means magnetic field will be in this region. That means inward. The magnetic field will be inward. Then using this cross product, you can calculate the direction of magnetic field. So this is the one position. Number two is magnetic field due to infinite wire. Magnetic field due to infinite wire. So the length of this wire is infinite. So if I take this point, then the angle, this theta 1. So if I take this and this, then the theta 1 is increased. If I take this point, then theta is increased. If I take the infinite length of this wire, then the angle will be 90 degree. So in this region it will be a 90 degree. So in this will theta 2 will be 90 degree and theta 1 will be 90 degree. So for infinite long wire, both the angle will be 90 degree. Then theta 1 equals to theta 2 equals to 90 degree. So put this value on this equation, then it will be b equals to mu 0 I by 4 pi d into sin theta equals to sin 90 degree, that means 1 plus 1, that means it will be mu 0 I by, here it will be 2, here it will be 4 pi d, then it will be 2, that means mu 0 I by 2 pi d. This is the magnetic field due to a infinite long wire. If I want to calculate magnetic field due to a semi infinite wire, so number 3 is magnetic field due to semi-infinite wire. How to calculate? Now this is, suppose this is point P at a distance D, and this angle will increase, and for the infinite length of this wire it will be 90 degree, that means theta 1 will be 90 degree, but there is no length in this region of this wire. That's why the angle theta 2 is 0, because there is no length, then angle will be 0. So if I put this value, then theta 1 equal to 90 degree and theta 2 equals to 0 degree. If you take in this case, if you take at this point, then theta 1 will be 0 and theta 2 will be 90 degree in this case. So both will be equal. So magnetic field will be mu 0 I by 4 pi d, here is sine 90 degree plus sine 0, so it will be 0, so it will be mu 0 I by 4 pi d. This is the magnetic field. So magnetic field due to a semi-infinite wire we have calculate here. Now we have to calculate the magnetic field on a axial point. So if you want to calculate magnetic field on a axial point, so number 4 is magnetic field on a axial point. So suppose this is a wire, so if you want to calculate magnetic field on the axis of this wire, this is point X, and if you want to calculate magnetic field on the axis, suppose this is point Y. So if you want to calculate magnetic field on X or on Y, so how to calculate? here you see that this is the point O, suppose. So suppose this point is here. Suppose this point is here. Then you have to calculate the theta 1 and theta 2. Here is theta 2. In this case theta 2. This is a theta 2 and this is theta 1. So if this point is here, suppose this point is here. Now if I take the value of theta 2, here is theta 2, suppose, and this will be along this, here you see that this theta 2 will be increased. Here is theta 2 is increased. The value of theta dash and theta, here is theta 2 dash greater than theta 2, and theta 1 will be greater. Here is theta 1 dash, that means theta 1 dash is greater than theta 2. So here both the angle will be 90 degree. Both angle will be 90 degree. Both angle will be 90 degree. But we have taken theta 1 in this direction. When I deduct this formula, we have taken that theta 1 along this direction and theta 2 along this direction. But here you see that theta 1 in same, theta 2 in same direction. So theta 2 will be 90 degree, plus 90 degree. But theta 1 is reverse direction, in opposite direction compared to this direction. So it can be theta 1 will be minus 90 degree. So here is how to calculate the magnetic field on an axial point using this formula. If the point is here, then the angle theta 2 and here is theta 1. In theta 1 is opposite direction compared to this direction. Now if this point is near to this axial point, axial, suppose this is x dash, then the theta 2 will increase compared to theta 2. Then here the theta 1 dash is increased compared to theta 1. So when this point is going to the axis of this wire, then both the angle will be increased and it will be maximum is 90 degree. But when I deduct this formula, theta 2 will be taken in this direction and theta 1 will be taken on this direction. And here you see that theta 1, theta 2 in same direction. That's why theta 2 is plus 90 degree. But theta 1 is in the reverse as compared to this. So that's why theta 1 is minus 90 degrees. So if I put this value on this equation, so it will be mu 0 I by 4 pi d. So it will be sine minus sine 90 degree plus sine 90 degree. So it will be mu 0 I by 4 pi d. It will be minus 1, here it will be minus plus 1. So it will be 0. So mu 0 I by 4 pi d into 0 equals to 0. So at this point magnetic field is 0. Similarly, in this condition, theta 1 will be plus 90 degree and theta 2 will be minus 90 degree. So in this case, in this point magnetic field will be 0. So we have learned that the magnetic field on an axial point will be 0.